Hello, geometry students. Mr. Zacek back and better than ever here. We're rolling along in Unit 5. We're going to finish it up pretty quick here. And this is Lesson 6. We're going to look at inequalities in one triangle. So when you hear that word inequality, we should be thinking like less than, greater than, less than or equal to, greater than or equal to. Those are inequalities that we have here. So the first one is a corollary, and that's derived off of the exterior angle theorem, and it's this: the measure of an exterior angle of a triangle is greater than the measure of each of its remote interior angles. So recall from before that in this diagram, measure of angle 1 equals measure of angle 2 plus the measure of angle 3. So it makes sense to understand that therefore angle 1 must be greater than angle 2 and angle 3 because it's bigger than the sum. So, you know, something that's fairly obvious, but we're just kind of defining it more specifically. Now our theorem here is that the longest side of a triangle is opposite the largest angle, and the shortest side of a triangle is opposite the smallest angle. So let me give some angle measures here. Let's say that angle C is 30 degrees. Angle B is, let's say that it's 65 degrees. And if we had 30 and 65, that would leave angle A to be 85 degrees. So in this case, when we see that word opposite, opposite side 30 is side, so the 30-degree angle is across from side AB. So AB is going to be less than the 65-degree angle. What side is opposite that? AC, which is going to be less than our last side, which is across from the 85-degree angle, which is side BC. Okay, so down here we have shortest, up here we have the longest. Okay, just a little note, verify which order you're being asked for. So like on a quiz or in an assignment, most people get this. It's pretty intuitive. So the challenging part sometimes, or the part that people can trip people up on, is that if you know, they ask from longest to shortest or shortest to longest. So just make sure that you pay attention to that when you're being asked that question. All right, and then the triangle inequality sum. The sum of the length of any two sides of a triangle is greater than the length of a third side. And I just want to demonstrate this to you. If this is our triangle here, and we have a length here, and let's say it's like this side is really, really short. Well, if this doesn't happen, like if those sides don't touch, then there's no triangle. So what do we have to have? Those two sides have to be longer than the third side in order for that to form a triangle. So any two sides of a triangle is greater than the length of the third side. That's what we're saying there. Otherwise, you can't have a triangle with those lengths. So let's just do some questions that'll be the type of things you'll see with this. All right, so in this triangle, list the sides of triangle TUV from shortest to longest. So first of all, I would like to establish what are the angles on the inside. So we've got 62 and 58. If we add those two together, we get 120 degrees. So if the measure of angle T plus 120 equals 180, so therefore the measure of angle T is going to be 60 degrees. Okay? Now these are all pretty close, so we have to use this order. So 58 is the smallest angle, so the shortest side would be TV. Okay, that side is going to be less than 60. That's our middle angle, UV, which would be less than the final side here, which is TU. Okay. And for number 2, we can kind of flip that around. So in this diagram, SO is 6, OX is 5, and XS is 10. List the angles in order from smallest to largest. So the shortest side that we have over here, this is our shortest side, is opposite angle S. So you have angle S, then the middle side, 6 is opposite of angle X, and then the last side would be angle O. And then again, I just check smallest to largest, make sure that I have those in the right order. Okay, so now we have, can triangles have sides with the given lengths? Explain. So here's how we do this. So is any two sides greater than the third side? So 3 plus 7 is greater than 8. That's true. So 7 plus 8 is greater than 3. Obviously, that's true. And what's the other combination? 3 plus 8 is greater than 7. That's also true. So yes. Okay, that's possible. How about this one? 5 plus 10, is that greater than 15? That's false. So since those two sides aren't more than the third side, they're equal to the third side, it's not possible. And then in our, this one here, 2 plus 6 greater than 9, that's false, that's not true, so therefore it's not possible. So any two sides have to be greater than the third side. All right, and that gets us to our final type of question that we're going to be asked. Two sides of a triangle of a sandbox are 5 and 8 feet long. What is the range for the possible lengths of the third side? So here's the idea. It's there's an inequality. The difference has to be less than the third side, which has to be less than the sum of the two. So let's plug that into this one here. So 8 minus 5 is the difference. Here's our third side. And the sum is 5 plus 8. So the difference would be 3. The third side, 5 plus 8 would be 13. So it has to be between 3 and 13. It can't equal 3 and it can't equal 13. It's got to be between those two. All right, so nice kind of short lesson, pretty straightforward. We've got one more lesson in this unit. That's also a quick one, but good luck on this, and go ahead and ask any questions that you have to clarify this. Good luck.